Hey guys, welcome. This is our 2.5 video, and our heading is literal equations and formulas. So today we're going to be talking about rewriting and using literal equations and formulas. So first of all, what the heck is a literal equation? Let's go ahead and write this down right here. A literal equation is an equation that involves two or more variables. So when we say literal equation, it just means we're going to have multiple variables. Now we've looked at solving for the variable x primarily, but what happens when there's more than one variable? We would call this a literal equation. We have more than one variable, and we can still solve for a certain variable. It just means we won't get an answer like 10 or 15. There could be another variable in it. And this leads us to our next piece. And a literal equation leads us to what's called a formula. And a formula is an equation that states a relationship among quantities. So I'm going to actually have you write down these pieces right here. So go ahead and write down a formula as an equation that states a relationship among quantities. And then I want you to go ahead and write these formulas down. So these are all examples of formulas that we're going to be seeing in our math career. Perimeter, notice, all of these have more than one variable in it. So these are all literal equations, but formulas help us go ahead and calculate a certain aspect or thing with a bunch of different unknown things. Normally we're going to have to know them to obviously solve them, but these are examples of literal equations. Okay, so pause the video and get those down. Let's go over a couple examples. Okay, so here's our first problem. This is problem 1. It says solve the equation 4 equals 2m minus 5n. Solve it for m. Okay, so that's our first task. So I'm going to go ahead and rewrite this. Now, what's confusing about this is I am solving for just this piece right here, the m. That means everything else I need to get rid of. And this is very similar to what we do on a two-step equation normally. We're going to be going ahead and using what's called SADMEP. We're going to try and get rid of everything that is adding or subtracting to m, anything multiplying or dividing, and then if there's any exponents or parentheses. So right now, 5n is subtracting my m, so to get rid of it, I'm going to add 5n. Now these cancel out with each other. When I add 5n over here, these are not like terms, so they don't combine. Normally we just have a 5, no n, and they would combine and we get 9. Here we're not going to get 9, we're going to actually just get 4 plus 5n. So literal equations trick kids up because they want to combine those, but they're not like terms, so you can't combine them. Then we're left with 2m. So notice very same process. Actually, I think literal equations are actually easier because I don't even have to combine the 5 and the 4. They stay separate because they're not like terms. Then next we're going to go ahead and divide by 2. And we get 4 plus 5n over 2 equals m. And this is a literal equation. So we just went ahead, we had more than one variable, and what we were able to do is we were able to go ahead and solve for one of the variables, in this case m, in terms of the other variable, which was n. Okay? The second part of this question just asked me to plug in and solve. We're actually going to go ahead and just skip that for now, because I'm focusing on getting that literal equation solved for. Alright, let's continue. Okay, so that last problem we had variables, 2 of them, and then we also had some numbers. This one, we only have variables. So we have the equation negative t equals r plus px. Okay, so we want to go ahead and isolate, solve for only the x portion. And again, I'm highlighting this because I'm letting myself know I need to get rid of the other 2 items. So on that side of the equation, r and p are there, I need to get rid of them. So to get rid of them, we're going to use the same tactics that we've used before. And I'm going to write SADMEP again. I'm going to continue to write it, and that's because this is how I'm going to undo my equation to get x alone. Anything adding or subtracting, the r is getting added onto this, so we're going to go ahead and get rid of the r. Since the r is positive, we're going to subtract it. Again, will t and r combine? No, they won't. So I'll get a negative t minus an r equals px. Then we see that p is right next to x, so they are multiplying. So we are going to go ahead and divide by p. And I'm going to divide this side by p. Whatever we do on one side, we do the other. This will cancel. And we'll get x equals negative t minus r all over p. So that's a literal equation where we literally have no numbers, but we can still solve and we still treat those variables in a very similar way to numbers. The only difference is I'm not combining them. This would be a normal problem if that negative t was a 5 and r was a 2, then we'd actually combine the 5 and the 2, and then we divide by a p. But in this case, we are just going to go ahead and leave the variables separate because they do not combine because they're not like terms. Okay? T, R, and P all would mean something in this formula. T could stand for time, R could stand for rate, and P, I'm not sure what P could stand for, but it could stand for something. Maybe pool size? I don't know. Okay? Let's see if we can look at one more. Okay, this will be our last one. Kind of a long one, but I thought this one was cool because it will go right past us, which is kind of cool. But here we go. The Pacific gray whale migrates annually from the waters near Alaska to the waters near Baja, California, Mexico, and back. The whale travels a distance of 1,000 miles each way at an average rate of 91 miles per day. About how many days does it take the whale to migrate one way? Okay, so it travels 5,000 miles each way at a rate of 91 miles per day. So we had this formula, D equals R and T. Okay, well, let's see. Let's go ahead and figure out what we have. Well, 5,000 is the what? Distance. And then let's see. We have a rate of 91 miles per day. So we have the rate. What am I trying to find? I am trying to find how many days. How many days? So how many days would be time? Okay? So there's two ways I can do this. I can plug this in and then solve for time. Or I can take the literal equation here and I can solve for t and then plug stuff in. I'm going to do that first, actually. I'm going to go ahead and I'm going to solve for t. So to get rid of the r, I'm going to divide both sides by r. So now d over r is going to equal the time. So I changed my literal equation. I solved for what we're looking for, which is time. And now I'm going to plug in. Again, d was 5,000 miles at a rate of 91 miles per day. What is the time? Go ahead and grab our calculator. And we got 5,000 divided by 91. And we're going to get, and it says about how many days. So I get 54.9. So we're going to round that to, I don't know why I made two little swoops on that T. I apologize. Let's try that again. It's going to be approximately 55 days to go ahead and take it. So again, we can take an equation that we know, distance equals r times t, and then we can go ahead and manipulate it, because it's a literal equation, and then we have it solved for the right thing that we're looking for. Okay? Alright guys, toodles. I just said toodles.